Isaac Newton was an English physicist, mathematician, and astronomer who is widely recognized as one of the most influential scientists in history. He made groundbreaking discoveries and formulated important theories that laid the foundation for modern physics and mathematics. Some of his most notable contributions and theories include laws of motion. Newton formulated 3 fundamental laws of motion, known as Newton's laws of motion. The first law, also known as the law of inertia, states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an external force. The second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This is often expressed as F ma, where F is the force, m is the mass, and a is the acceleration. The third law states that for every action, there is an equal and opposite reaction. In other words, if one object exerts a force on another object, a second object exerts an equal and opposite force on the first object. Universal law of gravitation. Newton proposed the law of universal gravitation, which states that every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This law is expressed by the formula Fg mon n2 r2, where F is the gravitational force, g is the gravitational constant, mon and n2 are the masses of the objects, and r is the distance between them. Calculus. Newton and German mathematician Gottfried Wilhelm Leibniz independently developed calculus, a branch of mathematics that deals with rates of change and accumulation of quantities. Newton's work on calculus laid the foundation for many scientific and engineering advancements. Optics. Newton conducted experiments with prisms and developed a theory of colors, showing that white light is composed of a spectrum of colors. He also made significant contributions to the understanding of how light is refracted and reflected. Laws of cooling. Newton studied the cooling of objects and formulated the law of cooling, which describes how the temperature of a body changes with time when it is placed in a different medium. Isaac Newton's work had a profound impact on science and our understanding of the physical world. His laws of motion and law of universal gravitation were revolutionary and formed the basis for classical mechanics, and his contributions to mathematics and optics furthered our understanding of these fields. His ideas continue to be influential in contemporary physics and mathematics.